Good afternoon, HVAC team. We're moving on to chapter 76, which is about commercial air conditioning systems. So let's do that. So chapter 76, the objectives are explain the differences between residential, commercial, and industrial air conditioning applications, list the different types of commercial air conditioning applications, identify the type of equipment configuration that best suits each commercial application. List the basic chilled water system, compressor, and condenser types. Describe the differences between single package units and rooftop units. Describe the general arrangement of a direct expansion coil in an air handling unit. And list list the different types of heating and cooling coils. Select the proper coil for a given application. So commercial air conditioning applications. There are many different types of commercial air conditioning systems because there are such a wide range of establishments. For example, a system designed for a hotel or motel may be very different from one that would be found in a movie theater. There are many different commercial applications, including restaurants, shopping malls, hospitals, and train stations, just to name a few. Commercial air conditioning applications. So again, there's hospitals, nursing homes, schools, colleges, and universities, airports, bus stations, ship docks and train stations, auditoriums, movie theaters, arenas, and stadiums. All examples of commercial air conditioning applications. This little rooftop package unit looks like it's on like a possibly a restaurant or something in a little strip mall. So for conditioning multiple rooms or spaces in a building, single package air conditioners, split system air conditioners, and rooftop air conditioners are most commonly used. Many of the smaller systems ranging from fractional tonnage room coolers up to about 20 to 30 tons are often referred to as light commercial systems. Office buildings. Small one-story office buildings may have individual unitary package systems for individual spaces. Multiple story buildings may use forced air with a rooftop central unit. This could be a rooftop forced air system or an air-cooled chiller. Very large multi-story office buildings often use a large central chilled water system located in the mechanical equipment room. So that's what you will see here. So this is your chiller, your compressor, evap, and condenser coil, all that stuff is here in your mechanical room, and then you have your cooling tower up on the roof, which would be here. Let's keep moving. Single packaged air conditioners. They come in two configurations, horizontal conditioner and vertical. Horizontal conditioner or horizontal packaged heating and cooling units with integral air-cooled condensers in the size range of 1.5 tons to 5 tons. Vertical conditioner, vertical self-contained air conditioners with water-cooled or remote air-cooled condensers is the size range of 3 to 15 tons. So there's different capacities between the horizontal and the vertical. So the horizontal unit usually uses ductwork for the distribution. The horizontal unit is completely self-contained, including the air-cooled condenser. It therefore must be placed either entirely outside or at least with the condenser section outside. A schematic diagram of the arrangement of parts is shown. So this is your package unit right here. You got your compressor here in the middle, your discharge line going out to your evap coil. This is your evap coil here. This is your blower motor. And so as it's turning, it's sucking the air across here and blowing it into the out into the supply air. So your duct, so this would be an over-under duct connection. So imagine if you had your return duct connected here and then your supply duct connected here. So it's going to be pulling in the return air, going over that coil. The heat transfer will take place. It'll come out and into your supply as conditioned air. And then over here we have our condenser, which is, so this whole entire unit will be on the roof. This is your suction line coming back. I'm sorry, this is your suction line. I'm sorry, this is your discharge line going into the condenser, not into your evap coil. Do not quote me on that. That was a brain fart. So your discharge going into your condenser, and then it's going to come out as liquid, feed through these distributors into your evap coil, boil off, and come out through the suction line as a gas and back into your compressor to do the entire thing again. But this here is your condenser coil. Your outside air is out here, so it's going to be, as this fan turns, it's going to be blowing air across these coils, and you're going to be moving heat. You're going to be releasing heat into the outdoor ambient air. Horizontal packaged air conditioners. The unit is primarily a cooling unit, although electric heaters can be installed in the unit. The unit can be equipped with supply and return duct connections. Ducts can be entered from the side or bottom, depending on the application. The unit can be installed on the roof. This type of application is used for shopping malls, factories, and other commercial buildings. So unfortunately, we have not had the privilege of going out on the roof. I get real close, but I just can't. I gotta play by the rules. I gotta stay professional. It's a liability going out there, but if we have the opportunity, we would see. We have package units this size. We got a few little tiny ones. It's all kind of stuff out there, but we have a few of these big package units that serve certain portions of the UEI campus. Now let me go back real quick. They had so they got strip heat installed here, so you can't actually see the heating coils, but they're here. If you were to unplug everything and pull this section out, you would see the heater coils in there. But yeah, you can install electric strip heat, which is that there. Oh, here it is down here. I'm sorry, I didn't even see that. So this is the electric strip heat, and it is inside. This whole long piece is inside here. So this little panel on the outside here, that's what we see over here. This side, the outside of this piece is what we see right here. And the rest of it is inside the cabinet. And it works just like a toaster. Once it's energized, these coils here will start glowing orange and generating heat. And then that blower motor is going to start turning, and it's going to pull that cooler return air into the air handler, and it's going to do its whole heat transfer from the cold air to the heater coils, and then you're going to have the warm air coming into the supply. So horizontal packaged conditioner. Water protection is a weather resistant. So these are the different features that come with the horizontal package conditioner. You have water protection, low ambient control, economizer, enthalpy control kit, fresh air kit, fan delay relay kit, and then anti-short cycle timer. So the water protection, a weather resistant cabinet along with a water shedding base pan with elevated downflow openings and a perimeter channel prevent water from draining into the ductwork. Low ambient control kits are available that control the condenser head pressure to permit the unit to cool at even low ambient temperatures. The economizer, an economizer and dry bulb temperature sensor can be supplied for downflow installations. This makes it possible to use outdoor air for cooling when outdoor air temperatures and humidity permit. Enthalpy control kit. This can be supplied in place of the dry bulb sensor, or two enthalpy controls can be paired to provide different enthalpy control, differential enthalpy control. So the enthalpy is just all the properties of the air. Fresh air kit. This can be mounted over the horizontal return air openings for downflow requirements. It also can be used on horizontal applications by cutting a hole in the return air duct or in the unit filter access panel. That method is a little, you just got to make sure you filter that. I've seen people cut holes into the return air, and then that was it, and that was their fresh air. And the problem with that is the filter was down inside the building in the filter grill, but the fresh air intake was up on the roof in the exposed duct in the return. So, in an exposed portion of the return duct. So all the air that's going into the return from inside the building is getting filtered, but anything that's coming through that fresh air vent up on the roof is not being filtered in that particular unit. Some account for that. When they put in a fresh air intake, they put in a bird screen or put a filter on it, or it'll be a unit where the filter is installed in the unit itself. I've seen that not be the case. I've seen them, like I said, the filter was down inside the building in a return grill, and filtered the return grill, and then the fresh air was up on the roof in the exposed portion of the return, and that coil was very dirty. Bird feathers, twigs, and weeds, and all types of debris, because it's sucking everything in. As the wind blows, whatever that wind's blowing across the roof is getting sucked into that fresh air intake and then getting jammed into the coil. So fresh air kits, if you're putting one in, use an actual kit, like the professional kit, and make sure it's all filtered and installed correctly so you don't ruin your coils. A fan delay relay kit. This control keeps the indoor blower on for about 90 seconds after the unit stops to improve the EER, which is our energy efficiency ratio. Anti-short cycle timer. A time off device ensures a minimum of 5 minutes off between compressor cycles. So that way you don't bring your compressor on and off all rapidly and short cycle it and ruin your compressor. You want to give it time for the pressures to balance out. So rooftop conditioners and air handling units. Rooftop self-contained and air conditioning units are commonly used on commercial installations. The sizes range from 3 tons to 130 tons of cooling capacity under standard rating conditions. Besides the difference in size of the components, individual units differ in the type of heating supplied with the package. A small residential horizontal air handler would have a direct expansion coil and a blower. This would be fairly simple. This would be a fairly simple type of air handler to install and service. Larger air handlers are more complex. In large air handler systems, the chiller supplies chilled water to the cooling coil located in the air handling assembly. So here you just got another rooftop package unit. That's the side of your condenser coil. It's an air-cooled condenser coil. Then over here, you have the cooling only horizontal flow air handler with a DC coil, and works the same way. It's air-cooled, air goes across there, comes out, and the heat transfer will take place, and you will remove heat from your system. Direct expansion coils. Many residential and light commercial air handlers will have direct expansion coils. These may come from the factory without refrigerant and pressurized with nitrogen. If this is the case, they should be checked for pressure with the installed Schrader valve prior to installation. Anytime you have a coil that's pressurized at the factory with with nitrogen, you always want to check and make sure that that nitrogen is still in there. That way, you know, you don't have a leak. And it's as simple as just pushing in that Schrader valve and waiting to hear a psst. Once you hear that, you know the pressure that they put in there at the factory is actually still in there, and you're good to move forward with your installation. Last thing you want to do is install the entire unit and then get all the way to the point of doing your evacuation, and then your evacuation never coming down, and then moving into leak checking to figure that out, and then find out that your coil has a leak in it. Well, actually, you wouldn't even get that far. Once you braze the system, you're going to pressure test it, and at that point, once you see that your joints are solid, but you're still losing pressure, then you're just going to feel cheated because your coil is leaking and ruining all your hard work. So definitely check your coils. If you got something that's a condenser coil or evap coil that's factory charged with nitrogen, it'd be wise to check it at the supply shop if you can before you even go back to the job site. Just push that Schrader valve in and make sure you got pressure in there. So direct expansion coils. Once the connections have been cut off, they should be prepared for flaring or brazing. A liquid line filter dryer should be installed as close to the coil as possible. And that is to protect your metering device. You want one directly before your metering device. Even though there's already one in the condenser, usually it's still recommended to install one right at your at the evap coil, right before the TXV. Okay. Whoa. Let me go back. This thing is a little sensitive. All right, so when brazing a thermostatic expansion valve, always direct the flame away from the valve body. As an added precaution, a wet cloth should be wrapped around the body and element during the brazing operation. After the proper fittings have been soldered, the TEV or TXV, same thing, can be installed. If the TEV is externally equalized, run both the temperature sensing and pressure sensing lines to the coil outlet. Staging and hot gas bypass. Generally, some type of staging control system is used. With a change in load demand, the compressor may be staged to start or stop. A liquid line solenoid valve can be used for capacity control. Another type of staging is unloading. Rather than allowing the compressor to continually cycle with demand, unloaders are often used to cut out individual compressor cylinders or banks of cylinders. It's a big chiller right there. So chilled water cooling coils. Chilled water systems are referred to as indirect expansion systems. A primary refrigerant will be used to remove heat from the secondary refrigerant in the chiller unit. The primary refrigerant remains in the chiller unit and operates. Sorry, let me scroll down a little bit. So the primary refrigerant remains in the chiller unit and operates on the normal refrigeration cycle. The secondary refrigerant, which is the chilled water, will be pumped to the air handler cooling coils and then return to the chiller. So the secondary refrigerant, which is the water, is what goes to the coil. So this big old system right here is nothing but a regular refrigeration system. It's just larger. You got your condenser coil here, your evap coil here. You got your compressor up here. You know, you got your metering device down here. Same stuff, same exact refrigeration cycle, but the refrigerant, but it acts like a package unit. So the refrigerant never leaves the system here, but it's because it's not cooling the air. We're used to cooling we're used to the medium that we're cooling being the air in the room. Chillers, we're not cooling or heating the air. We're cooling the water in the system, which is the secondary which is the secondary refrigerant. So the water goes into the evap coil instead of air. And when that water passes through the coil, it's a big tank of refrigerant, of very cold refrigerant. And so that very cold refrigerant is absorbing the heat from the water that's passing through it. There's a bunch of pipes passing through that big tank of refrigerant, and that water is coming out of the other end very cold because it's just been chilled by that refrigerant. The refrigerant absorbed all the heat from that water. That water shoots to each individual cooling coil in each individual space in that building. And then that's where they get their cooling from. And then that water that's going through that cooling coil, after the heat from the room passes over the cooling coil, now that water has absorbed that heat. So now that warm water is coming back to the chiller to get cooled again. And it's just making that constant loop. And that's how you get your cooling on a chiller. So rooftop conditioners and air handling units. Air handlers can be configured with both cooling and heating coils. The heating coil is located in the airstream before the cooling coil. The arrangement will help to reduce the possibility of the cooling coil freezing during cold weather conditions. Steam heating coils are more efficient than hot water heating coils, but boilers that generate steam fall under stricter regulations and require more safety controls. Therefore, many heating systems for residential and light commercial applications use circulated hot water rather than steam. The hot water for the heating coil is normally supplied from the boiler and will circulate from the boiler to the air handler and back again. This type of heating coil will have a bleed valve. Hot water coils should be piped for counterflow so that the warmest water meets with the warmest air. The hot water loop will include an expansion tank and a fill connection. Similar to a cooling coil, high quality distilled water should be used for the circulated hot water to prevent scale forming on the inside of the coil surfaces. Steam heating coils. An advantage to a steam system is that circulating pumps are not required. In a hot water system, pumps must be run to circulate hot water to the heating coil and then back to the furnace. For steam systems, let me go back. So for steam systems, supply pumps are not required. The steam under pressure will travel through the piping and into the heating coils. The condensate leaves the heating coil, through a steam trap. This is generally piped as a gravity or vacuum return to a condensate return tank. Coil cleaning and corrosion. Chilled water, hot water, steam, and direct expansion coil exterior surfaces must be cleaned regularly. The interior surfaces of the coils are often finned to help increase the heat transfer surface area. The finned coils provide, the finned coils provide an opportunity for dirt and grime to collect. One second. Sorry about that. So dirty coils reduce heat transfer and lead to increased operating costs due to inefficiency. On direct expansion systems, a dirty coil can lead to liquid floodback and compressor slugging. General corrosion is caused by oxidation and chemical attack on the coil tubing surfaces. Cleanliness is always a good thing. So in summary, packaged terminal air conditioners or PTAC units are most commonly used in hotels, nursing homes, and apartment complexes. Single packaged air conditioners are horizontal or vertical and are permanently located in a separate space away from the room being cooled. Rooftop conditioners are thoroughly waterproofed. Large air conditioning load capacities often require chillers. Air handlers come in many configurations and sizes. Commercial and light commercial handlers available as sectional units. All air handlers have a fan and a cooling and heating coil. Fan size, speed, and type of control will vary depending on space requirements. There are different types of coils: direct expansion, chilled water, hot water, and steam type. So that is all for Unit 76. Read your books, do your review questions, all that good stuff. Hopefully everybody's staying motivated, staying healthy, staying safe. And I'm gonna keep on, bringing more and more of these lectures until we get back to the classroom. So hope it was helpful. I will see y'all on the next one.